The screenshot below shows a probability distribution for a continuous random variable x, where x is normally distributed with a mean of mu and a variance of sigma squared. The area of the unshaded region to the left tail is 0.025 and the upper tail is 0.05. The lower bound of the shaded region is 13.3301 and the upper bound of the shaded region is 20.5397. Calculate mu and the variance sigma squared. Y is the random variable 2x plus 5. Write down the distribution of y and hence find the limits within which the central 90% of the distribution lies. Okay, to do this then we need to find the corresponding z values which go with this distribution. So the boundaries here that goes with the z value goes with that, and the z value that goes with that. Remembering that z is normally distributed with a mean of 0 and 1. So we need to do 5 to the minus 1 of 0.0025. So if we go to our calculator, enter the statistics menu, so number 2. Okay, and then go F5, and we want normal F1, and we want inverse normal. Okay, so we want left, and we want that area to be 0.025. Enter. We want the mean to the standard deviation to be 1 in this case, and the mean to be 0, and that should give a value of minus 1.95996. Okay. And then for the upper bound, we need to consider 0.95. If we want 5% there, we want 95% here. So going back to our calculator, and going back one step, and then changing that area here to 0.95, and enter, that gives 1.64485. Right, so now we know that z is x minus the mean over the standard deviation, and then the standard deviation times z plus mean, the mu, is equal to x. So we set up simultaneous equation. We take that value to go with that value, and that value to go with that value. So we get, you need to write down the simultaneous equations. So we get minus 1.9556996 times the standard deviation plus mu is equal to 13.3301 for the lower bound, and for the upper bound 1.64485 sigma plus mu is equal to 20.5397. Now you can solve this either manually or use the calculator. It's actually quite easy to manually because you just subtract the two. But we'll use the equation solver on the calculator. So going to the calculator and then pressing menu, and then we need to go down to equation on this one, enter. We want F1, okay, and we want F1 again because we've got two unknowns. We've already got data in here, so let's just get rid of it and then start again. And then, okay, so putting in the information, so we've got minus 1.95996, enter. Now, because it's 1 times the mean, it'd be 1. And then we want that lower bound given in the question, which is 13.3301. Enter, and then we put the upper bound in with 1.64485. Enter. 1 for the mean, and then put that upper bound that we get. If the question said detailed reasoning, well, that's going to not be right. If the question says detailed reasoning, do not use this method. Use. Okay, right, and then we press F1, sorry, we can solve it. So we're going to get now remember that x actually stands for the standard deviation here. So we're going to get 2 for the standard deviation and the mean 17.25. So writing that down, so using the equation solver, it will give, remember the first one is 2, and then the first one is the standard deviation, and the mean is 17.25. But remember, we want actually the variance for the answer. So, hence, the mu, the mean is 17.25, and the variance, sigma squared, is 2 squared, which is 4. Right, then we've got this new distribution, which is distributed with 2x plus 5. To find the new mean, we need to do 2 times the mean of the previous one plus 5. So it's 2 times 17.25 plus 5, which gives me 39.5. And for the variance, we're going to do 2 squared times the variance of here. You don't need to add anything for the variance. So it would be 4 times 4, which is going to be 16. So my new distribution, and the parameters of the normal distribution mu and sigma squared, will be 39.5 and 16. But remember, if we're going to find any probabilities, we need to take the square root of that on the calculator. So we require the probability, we want the central part of the limits of the central part within which y lies, that the central part is 90% or 0.9. I like to draw a diagram. So it's 39.5. Sigma is the square root of 16, which is 4. And then we want this area here to be 0.9. Now the calculator actually does this quite nicely for us, just making sure that we put the right values in. So let's go back to the calculator, okay, and then press the menu and then go to the statistics menu, which is number 2. And then again, we want distribution, which is F5, and then normal, and then we want inverse normal. Okay, now we want, instead of left, we now want the central, which is F3, and we want the area, exit that, sorry, X down to one more, the area to be 0.9, so 0.9, enter. Okay, so my new standard deviation was 4, and my mean was 39.5. So make sure you put the right standard deviation in here, because you could make a mistake. Enter, and that will give me the two values of 32.92 and 46.079. Okay, so from the calculator I get these two values, and then we'll round them correct to 3 significant figures. So we get that y must lie between 32.9 and 49.1. So there's been a video to show you how to use the how to find the mean and the variance, given some information, and then using some coding and using that distribution to find some limits of which part of the distribution lies. I hope you've understood, and I thank you very much for watching.